Good evening, gentlemen. As suggested, today our topic of discussion will be engineering economics. So, first, we would like to know what is engineering economics, why it is applicable in safety, and in which area we will be using it, from which level of management will be looking forward for these kind of data. All these stuff we will see in this chapter. So, I will go line by line in order to understand the explanation more in detail. And in between, I will give a scenario or explaining it in more detail. So, engineering economy is a subcategory of economics that is specifically designed for the engineering professions. Okay, safety profession is considered to be part of engineering profession. The essential idea behind engineering economy is that money generates money, right? If you put money, you can take money. Okay. An amount of 10,000, sorry, $10 today cannot be compared to $10 a year from now without adjusting for the investment potential. Okay, what is investment potential? The inflation data, the interest rate, or the compound rate per year, per month, or per day, wherever you deposit this amount. Okay, and how much the return it's going to give. If we don't know, we can't tell after 10 years how this $10 would look like. Some may be curious at this point as to what economics has to do with the safety profession, right? So many might be having a question within you, if you're a safety profession, why we need to consider all this stuff. Regardless of what some safety professional may believe, safety is a business unit. It's a business. End of the day, it's a business. Some examples of this are a safety manager requesting the company to authorize funds to purchase safety equipments to reduce the number of specific types of injuries. So, for an example, put yourself in a safety manager roles and responsibility. You want to convince the management in order to authorize and approve your request to purchase few safety equipments to avoid some kind of particular safety injuries which are repeatedly happening based on your trend analysis or whatever the stuff you do. Second one, the safety manager requesting to purchase a computer based training program in order to shift face to face training program. A safety manager has 8 different manufacturing facilities with a central safety budget and must determine where to spend allocate the funding. A safety manager and professionals are often asked to justify expenditure in economic terms and not just in terms of it's the right thing to do. So, as we all know, it's a pretty challenging time as a safety profession. In daily, day-to-day life, we face this with the top management. Whenever we go with the recommendations or the control measures to the management in order to put in place, there will be always a person to ask what's the return for investing on this recommendation, right? It's a pretty straightforward question. How we can answer these type of questions from the management, or how we can convince them with the data? Okay, if they are going to apply your recommendations, what is going to be the return, ROI, return on investment? Okay, within how many years they can get that return back? For an example, you propose a type of instrument or the guarding which need to be installed for all the similar machines which are present around 1,000 locations of your company. Just creating a scenario. Okay, how much cost it's going to uh, bear for the management? So it will be a huge. It's not only for single machinery, 1,000 units. Okay, 1,000 locations. So the cost will be high, and if you are not justifying the economic units or the statistics data of the incident as well as the return of investment statistic data to the management, they will not be convinced to move forward for implementing your recommendations. Okay, instead of engineering control which you brought, they will simply ask you to go forward for the PPEs or the administrative controls, which will be easy for them uh, to implement, right? So these are the practical situations which we need to look into it, and we have to grab this chapter very well so that in day-to-day life we can easily apply these concepts. It will be pretty challenging for us also in order to calculate all this stuff in the numerical things, but challenging is our part of roles and responsibility as a safety profession. Okay, let me continue. When equipped with viable information on the associated cost, including the cost of money, requests are more likely to be approved. Okay. At this point, it is worth mentioning that not all safety expenditures are based entirely on financial decision making process. In this chapter, the present and future value of money, interest, and various payment structure as they relate to safety will be our primary focus. So let me go through the formula sheet as well. The key uh, formulas related with the engineering economy which are provided in our formula sheet. If we come to page 6 on the left hand side middle part, we can see all the formulas. So let me explain the terminologies in the formula quickly, then we will move on with the chapter. F is nothing but the future value. Okay, P is nothing but present value, I is nothing but interest rate. Take a note, I will be always substituted in decimal. In question, they will represent in percentage, but when you convert or when you apply that in the formula, you should convert the percentage to decimal and then apply in the formula. How you convert percentage to decimal? Just simply divide the percentage by 100. For example, in the question they are given 10 percentage annual interest, then you have to just divide the 10 by 100, you will get zero point 0.1, okay, as a decimal unit. Then in I place we have to substitute zero point 0.1. N is nothing but number of years or number of months. It all depends on the interest rate. For an example, if the interest rate is given monthly, then your N has to be substituted in a monthly basis. If the interest rate is provided in early basis, okay, then your N will also represent yearly. Okay, the right hand side formula is just a reciprocation of left hand side. Okay, so they kept P and shifted all the other terms to the left hand side. So automatically it comes to the denominator 1 plus I to the power n. So the whole term, if it goes to above, this minus symbol will come. So it's just a reciprocation of left hand side formula. I will not recommend you to by heart the formula. Just practice the formula a couple of times to have a understanding. But the main thing what you need to get from this chapter is how practically we can use all these concepts behind the formula in our day-to-day exposure. Okay, that is what more important, and that is the objective why this chapter is added in your syllabus. Okay, F is nothing but again future value, and A is nothing but the recurring value or the recurring deposit or the annuity value. Okay, what is that? For an example, every month I pay SIP. systematic investment plan. For example, $100 I pay every month in a bank which is giving me 5% interest rate in a month. Okay, this situation I am creating. Okay, imagine the bank is giving 5% interest rate every month, and in that bank I am depositing $100 per month. Okay, so repeatedly for 5 years I am doing this. Every month I am depositing $100. Then this $100 will be your A value, which you are repeatedly doing it for the number of months, and the total period is 5 years. And I again is the interest rate. N again follows the same concept what we have discussed right now. Other all terms we have discussed already. And the right hand side formula is just a reciprocation of left hand side. And the last formula, the third line, it represents the correlation between present value and the attenuity value. Okay. So in the question for an example, if they give present value and if they ask A attenuity value, then you will go with this one. Okay, right hand side, last formula, third line. And in the question, if they give a future value and they ask a present value, then you can go with this formula. So based on the question, what it is expecting, we will pick the formula and we will use it. Okay, so now let us jump back to the book. Let us see from the simple interest. Actually, this formula is not in your formula sheet. Okay, simple interest and compound interest, both we will see, but we will see more practical related questions in favor of compound interest. So first let us understand what is simple interest. When borrowing money, the lender will, under normal circumstances, charge interest on that money, right? Cost of money, they call it as cost of money. When the loan is paid back, the borrowed amount, okay, and the interest rate are paid back. So for an example, I am the borrower and you're the lender. You lend me 1 lakh, for an example, 1 lakh INR. Then I will return you 1 lakh, which is the principal amount, as well as the interest rate what you say. Okay, initially we will have an agreement on the particular interest rate and then we will move forward of it. So after 1 year, if you keep the interest rate is 10%, so I will pay you the 10% interest rate with the principal amount. So for calculating this stuff, they have a formula which is nothing but I is equal to P multiplied N multiplied I. So I will recommend you to remember this formula and the terms. What is I? The amount of interest paid. Next one, principal amount P. Next one, N is nothing but number of years or the period, time period. Next, I is nothing but the interest rate. As I told, I should always be substituted in decimal format. So now let us see a quick question to understand it more in detail. Your company would like to refit one of its processing lines and has determined that the cost to do so would require $50,000. Okay. You are asked to calculate the total cost of the project if the interest rate is 6% annually and the loan repaid in 3 years. What is the total cost of the project? So here your company is going to get $50,000, and every year the interest rate is 6,000, sorry, 6 percentage annually, and the loan period is for 3 years. So now they are calculating the interest paid for this 3 years and they will add it to the loan amount, which is the principal amount. So for an example, here take this question, apply in the formula what we have discussed. P is the principal amount, which is $50,000. N is number of year. In question they given 3 year, and I is nothing but the interest rate, which is 6%. So divide the 6 by 100, you will get 0.06, which they substituted here. Now you know the total interest you will be paying for 3 years, total 3 years. Okay, after end of 3 years, what you will do, you will not only give this $9,000 to the lender, you have to give the principal amount also. So principal amount plus 9,000, altogether you will be returning 59,000 to the lender. Okay, this is very straightforward question, and it is related with the principal interest. Now let us discuss about what is compound interest. Okay, listen carefully, because once you understand the explanation of compound interest, it will be easy to understand the question. Most lenders charge interest by using compound interest method, which means that in addition to the principal, the amount of interest charged is also charged interest. This addition is called compounding. Okay, now see the example in order to understand it more clearly. Now I am taking a loan which is of $10,000, is charged an interest rate of 5%, which is compounded monthly. Okay. Therefore, at the end of first month, the loan balance would be 5% of 10,000. How you will calculate 5% of 10,000? Let me open the whiteboard to explain it will. So 10,000, 5% of 10,000, how we will calculate? 5 divided by 100. Okay. So if you multiply, it will come 500. So you have to add to the principal amount. At the end of 1 month, I need to pay them back 10,500. If I am not paying after 1 month, on the second month, how much the fund will be total? So after the second month, again 5% of this amount. Okay, 5% of this amount, if you calculate 10,500 multiplied 5 divided by 100. Okay, so 5% will be 5 to 5, which I need to add to the principal amount. Then at end of the second month, I need to pay them back this much amount, assuming there have been no payment to reduce the principal amount. So how we can transfer this ideology into the formula? They have used this formula. Okay, this formula is for compound interest. Future value, then the initial loan amount or the principal amount which is borrowed. I is interest rate, N is number of times per year interest is compounded. For an example, here every month it is getting compounded. So in a year, how much months we have? We have 12 months. So your N will be 12, because in a year it will be compounded 12 times. Next, T is nothing but number of years invested, or number of years uh, you are holding that loan in order to repay it. Okay, this formula is also not represented in the formula sheet. I will recommend you to just by heart this formula and the terminologies in the formula. Okay, now let us see a question to understand the concept more quickly. Your company has borrowed 10,000 from the lender, or imagine a person have borrowed 10,000 who charge the interest rate of 3%. So I'm taking a loan from you. Okay, $10,000. Now you are charging me 3% interest rate, and you want to charge this interest rate semi-annually, which is of 2 times a year. Okay, semi-annually. The loan will run for 3 years. So calculate the entire loan cost. So after 3 years, what is going to be the total cost? Okay. So what? How much I borrowed? 10,000 only I borrowed. Okay, which is of principal loan amount. What I have borrowed, $10,000. I will substitute in the formula. Then in the formula, 1 plus interest rate how much? 3%. And here n is how much? 2, right? N is nothing but 2. Why? What is n? Number of times it is getting compounded annually, right? So n will be 2 and t will be in this power n multiplied t. N will be 2 and t will be 3. T is nothing but the total time period. Here they given 3 years in total. So I multiplied 3. So simplifying this, you will receive 10,934.34. So at end of third year, you need to pay this amount in order to close this loan. Okay, imagining you are not paying nothing in between these 3 years. Okay, it is self-understandable from the question. Next, what we are going to see is the first formula in the formula sheet. Future value equal to present value, open bracket 1 plus interest rate, close bracket to the power n. Okay, so in the question, if they give present value, interest rate, and the number of year, and they ask the future value, you can go forward for this. Remember one thing, here in this formula, I will take n is equal to number of year. Okay, but in the previous compound interest formula, n is nothing but number of time the money is getting compound in a year. Okay, that is more important. And here in the same formula, I will explain you one logic. See here, what is the interest rate? 5%. 5% per year or per month. That is more important. So here they told monthly. So the interest rate is monthly, right? So I put interest rate here, interest rate 0.05 and divided by 12. Why 12? Because in a year there are 12 months. So I put 12. Then what will be t value? It is not explained actually, but I am explaining. If I substitute this thing, the same concept what they explained here in the formula, it will be like that. What will be t? What is t first? Number of years invested. So here, how much year they told? At the end of second month, the loan balance would be this much. So here they are calculating it everything in months. So the t will also be in months. You will just multiply 2, 2 months. Okay, n as per the terminology, number of times it is getting compounded per year, which is 12 for n, and t will be 2. Okay, okay. Now here in this formula, as we saw before, f is equal to future value, p is equal to present value, I is the interest rate, and it will also be represented sometime as APR. What is APR? Annual percentage rate. And n is number of years. So here they are given some examples. So the same example what is described here, they are considered in the formula, but let's see some example. A company XYZ has purchased a tract of land for this much value. What would be the value of this land in 20 years, assuming the interest rate is 9%. What is CAPR? Annual percentage rate. We consider that as interest rate, 9%. So direct substitution in the formula. Why? Because they given present value. At present, they given this amount and they purchase the land. And after 20 years, they are thinking how much it will be if every year 9% it's getting compounded. Okay. So your future value will be this much dollars. Okay. This formula is also not given in the formula sheet, but this formula is pretty useful in order to check the loan balance. Okay, personal life also, this formula will be very useful. Most loans, however, are not based on an end of loan payment, right? Once we take a loan, after 20 years, if we tell the bank, okay, total amount I will pay after 20 years, nobody will believe you. And the loan system doesn't work in that fashion. Most are made on the terms that you would begin making equal payments throughout the term of the loan. For an example, if you are taking 20 years loan, initially they will give you an agreement what is your payment cycle for the loan settlement. If you agree every month I will pay this much amount, they will calculate for that and they will tell you how much it's going to be at end of 20 years. Or if you tell every 3 months once I will pay, or every 6 months once, or every annual I will pay, which will be agreed in the beginning stage. So here there is an example on the basis of the previous scenario, okay, which is this one actually. Your company actually borrowed $10,000. You can determine your loan balance at the end of any given year using the following equation. So let's see uh, what the terminologies are uh, explained for. B, balance after T years. So for an example, I want to know the loan amount balance after 10 years. If the loan period is 20 years and I want to know the balance after 10 years, this formula I have to use, and B will be the balance after that many years. A is nothing but original loan amount or the principal amount what I borrowed. So here it is 10,000. Okay, originally I borrowed $10,000. I is uh, interest rate, they given APR. N, number of payment per year. So for an example, uh, every month if you are paying the loan back, how many payments you do? 12 payments in a year. So your N will be 12 in that situation. And T will be number of year. For an example, you took the loan for 20 years, then your T will be 20. So all the terminologies are pretty straightforward. Let's see some example. Your company has been made a loan of $10,000 from the bank and agrees to make equal installment payments of $100 monthly until the loan is repaid, and your interest rate is 4%. What is the balance at the end of 3 years? So here your original loan amount is $10,000. Your interest rate from the question, which is 4%, and is nothing but 12, right? Number of payment per year. So here you agreed every month you will pay $100. So you will be paying $1,200 in a year, which is every month you are paying. So it will be 12, right? And how many years you are paying? 3 years. This is T value, number of years in total, which is T. So all the values in the formula we got from the question. So directly applying the formula, simplify the values to know how much the loan amount will be balanced after 3 years. Okay, so if your company repays the loan at $100 per month for 3 years, the company would still owe $7,340 towards the loan. Okay. Okay. Now let's see the relationship between present value and future value. It's just a reciprocation of the formula what we saw right now. Let's see what is the explanation. Many times you will be asked to evaluate when investment will pay for itself based on savings. We can predict the time value of money using the following equation. So, as a safety manager, you can be asked this question. So, for an example, if I give $10,000 for your recommendation to implement, when can I get that back? Okay, when the investment will pay back. Okay, that can be asked by the top management. So here is the formula what we can use. Let's see example. Before we see example, we have to know the terminologies in the formula. P is nothing but present worth of the money. Okay, present value. F is future worth of the money or future value. I is the interest rate and N is the number of years, or it can be number of months also based on the interest rate given in the question. If the interest rate is given monthly, then you have to substitute N in monthly. If the interest rate is given in yearly, then you have to substitute N in yearly. It always depends on interest rate. Okay, let's see a question here. Focus little. If XYZ Corporation makes an investment of $30,000 to purchase safety equipment, and by purchasing this equipment, the company predicts it would prevent $10,000 in injury related cost. When will the investment pay for itself? So the management puts a question. I invest $30,000. When I can get it back? The annual interest rate is 12%. To calculate this, you must calculate each year individually starting with the first year. This point they will not give in the question. They will not guide you how to proceed on the question. So they may stop the question over here. So what they have done basically, before understanding that, we have to understand the question. They expect $10,000 will be the saving based on the investment what they do at present. At present, they invest this much, but they expect in the future it will save $10,000. Okay, so your future value will be $10,000, and every year how much it is saving. Okay, we need to know that. So we will add for every year. So for first year, how much is the present value for $10,000? And for the second year, okay, what will be the value for $10,000? Third year, fourth year, fifth year, sixth year, it will be keep on going. It depends on the total amount of investment they have done. Okay, so basically the question is asking you within how many years I can get the return back. So they expect the future value to be $10,000 of saving. From that, we need to determine the present value for every year, first year, second year, third year, and fourth year. So then you have to keep adding the present value together for the first year, for the second year, for the third year, and for the fourth year. So by fourth year, you are getting the value mentioned or invested. Okay, you will be getting $30,373.49. Therefore, it would require almost 4 years for the original investment of $30,000 to pay for itself. Okay, so it's a pretty what is it? It is pretty focusing question. Okay, if we miss to imagine ourselves whether the question is asking the present value or whether it's asking the future value, if we don't understand that specifically for each question in this chapter, it will be very hard for you to pick the formula itself. If you consider this $10,000 as A value, then you will directly go forward for this one, this formula, because you know I, you know N, and if you imagine this $10,000 is A value, then your entire assumption is wrong. So before you proceed or to pick your formula, read the question n number of time. I will not limit you read for 5 times, read for 10 times. It depends on the person to person understanding the question. So once you understand the question, proceed, or else just stop over there, read the question, spend some time on the question. You have to make yourself uh, understandable for the question. If you don't, then the entire time what you're going to spend is going to be useless. Okay, fine. This is how they frame the question basically. Okay, it will look straightforward, but if you miss to concentrate, then it would be difficult. Next, correlation between future value and recurring value or the attenuity value. You can just keep the formula or you can just by heart the formula, and this formula they call it as series compound amount factor. Now let's see directly the question so that it will be easy for us to understand. And this is how it is represented in the formula sheet. Okay, second line, left hand side, formula, a relationship between future value and attenuity value. Let's see a question. What would be the future value of a loan if you made equal payment of $100 at the end of loan period and the interest rate was 8% per year for 3 years? So what they tell here, you pay $100, okay, every year, and the interest rate is 8%, and you are paying it for the entire period 3 years. So you know the interest rate, you know n number of years, you know a, okay, a is nothing but each payment end of the period, which is already given in the question. Directly apply, you will get the answer. Now this formula is just a reciprocation of what we saw right now. They kept a and they moved all the terms to left hand side. Okay, you can compare and see, and this formula they call it as sinking fund factor. Why they call it as, just see an example. You have determined that the future value of a loan is going to be this much at an interest rate of this much over 3 years. You wish to repay the loan at the end of each year. What are your yearly payments? So they predicted the future value of the loan, which is F, interest rate they given, and number of years N they have given, and they are asking every year, at the end of every year, how much you need to pay. So they are asking A value, which is recurring value for continuous 3 years, first year, second year, and third year, how much you will be paying. So every year you will be paying this much amount. If you substitute the values in the formula, you can get the value. Okay. Okay. Uh, Next formula what we're gonna see is the capital recovery factor. Just see the formula. It's a correlation between attenuity value, which is nothing but the recurring value, versus present value. Before we saw the correlation between future value and attenuity value, vice versa of it. Now we're gonna see attenuity value versus present value and vice versa of it. Let us see the question. Focus. You are asked to assist with a capital improvement project that includes numerous safety related items such as life safety and National Fire Protection Association code upgrades. The total cost of the project is estimated by your engineer to be this much dollar. The owner currently has only this much dollar to invest in the project and will need to borrow the remaining fund. This part is very important. There is a 2.5 percentage of the total loan amount, loan origination fee associated with securing the loan. Determine the amount of money that the company must pay at the end of each year to repay the loan if it is locked in at an annual rate of 6.375 percentage compounded annually and loses all its value in 10 years. So number of year is 10, which is n, and I is interest rate, and what this percentage. Now that one will be explained here. The total value is this much, but you have only this much. So the remaining amount is the loan amount, right? So the remaining amount in the question they said we're gonna take the loan. But in order to take the loan, the bank is charging 2.5 percentage of the loan amount, and you have to add along with the loan amount because that is also chargeable to you. So 2.5 percentage of this amount you have to add along with this amount in order to identify the total amount, total loan amount, right? Because the admin fee for the bank is nothing but 2.5% of your loan amount which you have to bear. Okay, this part many people will miss out to consider it in the question. If you miss to consider, then your whole calculation becomes wrong. Now you know what is the total loan amount which gonna take, okay, at present. Okay, this is p value, and in the question they are asking every year how much you will be repaying. So they are asking a value. So we know formula a value and p value if they are correlated, and based on what question is looking for we will pick the formula. Okay, if I go to the formula sheet, question is looking for a value and they have given interest rate, they have given n, and we calculated the present value. So everything we know, just direct substitution in the formula. Okay, now we see one last uh, question related with present value and attenuity value. After seeing the chapter, I will explain few more example which I have taken up from another sample question book, which will give you more understanding how they will frame the question in the examination. Okay, so focus on the question directly. Using the information listed in the capital recovery factor section, okay, they are using the same concept which we discussed right now. Okay, the same concept. Let's see what they're going to tell. You have secured a loan at this much interest rate. They are changing the interest rate to this much compounded annually, and you have agreed to make annual payment of this much. They given the a value, so annually you will be paying this much dollar. how much money will be repaid on this loan at the end of 10 years. So after 10 years, how much money you will be repaying it. So they are asking how much money will be repaid on this loan at the end of 10 years. Okay, focus again on the question. Interest rate is this much, and annually you will be paying this much. How much money will be repaid on this loan at the end of 10 years? So they're asking future value, right? So here I hope we have to go with this formula. They given A value and they are asking F value, future value, and they given the interest rate every year, and they told the number of years which is in future, right? 10 years. So you have to pick this formula to proceed. Okay. Okay. I will read the summary. It will be a little interesting as well. Engineering economics continues to become an increasing factor in the day-to-day operation of a safety professional. As you can see from the few equations listed in this chapter, the structuring of a loan is an important financial aspect of any business owner or financial manager. In most cases, financial planners will provide the necessary financial information needed to finance a project. However, it is important to know the basic financial information in order for you as a safety manager to justify some of your recommendation. A well thought out recommendation will be received in a more favorable light by the final decision maker. Okay. So far we have discussed some of the examples and a pretty well known concept of engineering economy. Okay, now let's see few more questions to grab our understanding more or much in better way. Okay. Okay, we were seeing the fundamentals of these formulas. Let's go with the question. What is the present value of the future sum of $10,000 if the interest rate is this much and the time period is this much? So that's direct question. They asked p value, future value is given, interest rate is given, and number of years n is given. So which formula you will pick from here? Right hand side, first row. Okay, that formula you will pick and you will apply the value, you will get the value. Next we will see another question. What is the future value of saving $100 per month if the interest rate is 6% and the time is 10 years? So you have to be very careful. First, we have to identify what they are asking and what they are giving. So they are asking future value and they have given A value. What is A? Recurring value or the recurring deposit. So what they tell, every month you are saving $100 per month in some bank account or some mutual fund, or you have invested in some stock or crypto, whatever it is. It's giving an interest rate of 6% return. Imagine if they have not given anything, we have to consider that percentage of interest in years. Okay, consider 6% return in years it is giving, and the time period is 10 years. So before you substitute the values in the formula, you have to make all the variables in same line. So A value is in month.
Okay, you can keep it same. Based on a value, your interest rate and number of years will change. You have to convert this years. Okay, 6% interest per year, right? You have to convert that per year to per month. How you will do? First, convert the 6% to decimal. How you do that? 6 divided by 100, which is 0.06, is the interest rate per year. But you have to convert that per year to per month. So for that, in a year, how much months we have? 12 months. So 0.06 divided by 12, okay, will give you 0.005 interest rate per month. And 10 years, convert the 10 years to months, it will be 120 months. Now you converted everything in months. All are in same line. Then substitute the values in the formula directly. Okay. So which formula you will pick, that is also important. Go back. They are given a value, interest rate, and number of years. And what value they ask? They ask the future value. So you will choose left hand side, first formula, second row. Okay. They have not explained the formula here. That's why I'm going back to those slides to explain you much better. Okay, these kind of questions are little straightforward. Anybody can simply use the formula and derive the answer. But most of the question in your exam will look like this, and you have to spend little time to understand the concept behind the question and what the question is really expecting, and based on that you have to make a plan to execute the answer. So first let us read the question to understand it more better. Your company has decided to obtain a new machine for the production floor. There are two options for you. Now you are a safety manager or whatever the position you are. The company comes to you to get the guidance. First option you have is to lease a machine. Okay. Instead of purchasing, you lease it for 10 years, and every year you pay $2,000, okay, as a lease amount. This is your first option. Second option is to purchase the machine itself for $10,000, but every year you need to pay $500 for the maintenance of the machine. After 10 years of usage, what you will do? You will resell the machine and you will get $5,000 after 10 years. Okay, that they call as salvage value. The value of money will be 15%, okay, interest rate for 10 years. Number of period is 10 years. Which option do you recommend? Okay, either to lease or either to purchase. Which option is recommendable? So we are in a financial element, so we have to always think on the financial perspective. So whichever the option, the investment is less, the present investment is less, they will go with that, right? It's a normal protocol. The same protocol will be followed here. Okay, first we need to identify what is the present value for option 1 and what is the present value for option 2. Then we can compare. Okay, right now for option 1 I need to invest this much, and for option 2 I have to invest this much. So based on that, which option is having less investment, I will go forward for that, right? So for the first option, what they have given and what we need to identify. They have given a value. Okay, the time period is 10 years in total, but every year what you are doing, you are spending this $2,000 for leasing amount. So they given a, and they are given the time period which is n, and they are given the interest rate, and what we need to identify, the present value. as we discussed. Present value for option 1 we have to identify. So go back to the formula. Which formula we will choose? It is third line, first formula, left hand side formula. Okay, because A we know, I we know, N we know, and we have to identify the P value, which is present value for the option 1. For option 2, first we need to streamline the things. Let us read the option 2 again. You are purchasing the machine for $10,000, which means you are spending $10,000 at present. Okay, you go to shop and purchase that machine. Okay, Kalash, you pay $10,000 to the shop owner and you take that, which is present value itself, which is $10,000. But after purchasing that, every year you need to call the maintenance guy for the maintenance. So for every year, if you are spending $500, what will be the present value? Okay, so the 500 will be again A value, right? Every year you are spending for 10 years, you are going to spend $500 per year. So this is again A, and the same interest rate and the same number of year will be followed. Okay, then after 10 years, okay, after 10 years you are going to resell the machine and you are going to get $5,000. Okay, this is future value because after 10 year only you are going to get this $5,000. But for this $5,000 also you need to predict present value. Okay, so the second option is having three different things. One is $10,000 presently you are spending. In addition to it, $500 every year you are spending. So we gonna identify the present value for that $500 every year you are going to spend. We will use the same formula. Now your A will be 500, I will be 10, and sorry, I will be interest rate. How much it is? 15%. Yeah, and your N will be 10. Number of period is 10. So these two things you are going to spend, but the next one you are going to get it back, right? After 10 years, you are going to get back $5,000, but for that $5,000, you need to predict the present value. So which one we will use? Right hand side, first row. We know the future value is 5,000, interest rate we know, and N we know, and we are going to identify present value. So for this, they put minus. Why? Because first two things you are going to spend, and for the third one, you are going to get it back, which is minus. So after streamlining the variables on option 2, simply substitute the values, then do the math, identify the value. After you identify the present value for both the option, compare the value. Which one is lesser? Go forward for this. So here the best option is to go forward for option 1, which is leasing the machine. The cost is less. Okay, and the books which are provided to you will be having more question for you to practice. Just practice more and more and more question to clarify yourself on this chapter. If you feel any uh, difficulty on sorting out or solving the problems, you can always approach me for the clarification. I hope I made the chapter clear for you. If there is any question, approach me back to make you understand. Okay, so by this I will end this chapter. Thank you.